those notes, we are going to learn to identify terms and like terms. First, let's look at the definition for a term. When a plus or minus sign separates an algebraic expression into parts, each part is called a term. So let's look at the key word here, when a plus or minus sign separate. So if I look at this expression, 2 plus 3x, I have two terms, 2 and 3x. And we can see that each term is separated by a plus or minus sign. Now, here is one for you to try on your own. You should be underlining the terms that are in this second expression. All right, let's check your work. If we look, we see that there is a plus sign right here, and each term is separated by a plus sign. So my two terms for this expression would be 2y squared and 2y. The numerical part of a term that contains a variable is called the coefficient. So if we look right here, we have this term 3x. It says the numerical part of a term that contains a variable. X is our variable, and the numerical part of this is 3. So the coefficient in this term is 3. Why don't you try the next one on your own? Circle the coefficient. Okay, looking at this term, we have the term 2y squared, and the numerical part of this term is 2. The next vocabulary word we will look at is constant. A term without a variable is called a constant. If we look at this expression, we can see that we have 3 terms, 3z, 2x, and 8. They are all separated by a plus or minus sign. So a term without a variable is called a constant. This term 3z has the variable z. This term 2x has the variable x. This term 8 does not have a variable, so this would be our constant. Try the next one on your own. Circle the constant. Okay, if we look, we see that we have the term 6x squared and the term 2. 6x squared contains the variable x. 2 does not contain a variable, so that would be our constant. Our last vocab word that we need to understand to identify terms and like terms is like terms. Like terms. Like terms are terms that have the same variable raised to the same exponents. Okay? So, for example, if I have a 2x and a 3x, these are like terms because they both have the same variable, x, and we see that they are both raised to the same power, 1. Okay, here's another example. If we have the variable 2y squared, and then we have the variable 3y. These are not like terms, because like terms have to have the same variable raised to the same exponent. So if we look here, they both have the y, same variable, but they are raised to different exponents or different powers. So if we look here, we have y squared, so it's raised to the second power, and 3y is raised to the first power. So in order for these to be like terms, they have to have this same variable raised to the same exponent. So if I make this 3y squared, now we have two like terms. Now that we understand our new vocabulary, let's try identifying terms and like terms by looking at this practice expression. We have 6 minus 2r plus 7r plus r squared plus 9 minus r. So the first thing I need to identify are all my terms, and I'm going to do by highlighting each part of the expression that is separated by a plus or minus sign. I have highlighted all of the terms in this expression. Each term is separated by a plus or minus sign. Now I'm going to identify my like terms. First, I'm going to find my constants. Remember, constants is a term without a variable. So if I look here, I have the number 6 and I have the number 9. Those are like terms because they are constants. Next, I'm going to look at my second term. My second term is 2r squared. So I'm going to look and see if there are any other terms that have the same variable r raised to the second power. And if I look here, I see I have my 2r squared. 7r would not be the same because it is not raised to the second power. And then I come across r squared. R squared has the same variable r and it's raised to the same power, 2. So 2r squared and r squared would be like terms. So 2r squared and r squared are like terms. I'm going to circle them to show that they are like terms. Now last I'm going to look at my next term, which is 7r. Any term that had the variable r, just plain r, not raised to any power, would be a like term. So if I look, I have 7r, and then my last term is r. Those both have the same variable raised to the same power, so they are like terms. I have circled each set of like terms. I would like you to pause the video and try the next one on your own. Did you identify 9x and 3x as like terms? Did you identify 3xy and 4xy as like terms? If you did, great, you're on the right track. If you didn't and you still need some extra help, make sure you come see me during class.